All right, 6.1.2, what does it mean to divide? We're going to continue to construct different visual representations of fractions, and we are also going to work to make sense of long division, the algorithm of long division, which so many of you, I love the vulnerability out there. So many of you are like, can we talk about that more? I get mixed up. What does that look like? So we're going to do a little bit of that today. If you remember to yesterday when we talked about Isabel and Caitlin's visual models for representing 5 pieces of licorice shared among 3 people, we had to do a little bit of making sense of long division up here to find out if our fractions were equivalent or our quantities, our fair shares were equivalent, right? And so we had to figure out how many 3s fit into 5. We knew that we had one group of 3 in 5, and there are 2 left over, which then becomes our new numerator, and our denominator remains the same, okay? So I'm gonna read a little bit out of your textbook to you. Again, I'm going to talk about the problem. I'm gonna show you part of the problem, and then you are going to find a thinking partner to work on the rest of the problems with, okay? So by now, you are probably very good at working on basic division problems. For example, you can easily find how many teams of 3 students could be formed from a class of 36 students. Or you can probably calculate quickly how many eggs would be in each carton if 24 eggs were divided evenly into 2 cartons. Most likely, you've also learned how to do some more complicated division calculations, such as 208 divided by 16, or 346 and 76 hundredths divided by 10 and 25 hundredths, using long division methods, right? We've done some practice with that in our WIN blocks and in all of our math classes. So today we're gonna look at how are division problems like these related to dividing pieces of licorice evenly among several people. Can your methods and thinking in one situation be used to find solutions in another situation? I love that. That is what math is all about. Visual representations, and what do you know, and how can you connect what you know to something new that you're trying to work on, right? As we're making sense and persevering and using those math practices. All right, we're gonna be thinking about 3 questions today. We're gonna constantly try to ask ourselves as we are working with our thinking partners to work on lesson 6.1.2. What does this represent? What does it represent? Okay. How does it connect to what I already know? And how can I apply this strategy? So I love, that's the other thing I love about math. There are multiple ways to get to a solution. There are multiple ways to get to a solution. All right, so let's look at 6-15. When dividing licorice among her teammates, one of the students in Miss Yu's class exclaimed, "Whoa, we divided 7 pieces of licorice among 5 people, and each person got 1 whole piece and 2/5 of another. That's 7/5 of a whole. Is this just a coincidence? What do you guys think?" You're welcome to pause the video and think about that right now for a moment if you'd like. All right, what do you think? Does it make sense that 7 divided by 5 is 7/5? If we go back to using the visual up here with the division sign, talking about how the dot up here represents the numerator and the dot down here represents the denominator, right? It's like, maybe that does make sense. Okay, so Miss Yu students decided to explore this question using smaller numbers and asked, what if 4 pieces of licorice were shared among 3 people? 3 different teams drew the diagrams shown below. All right, so I have put these together and I'm gonna put them up here on our compendium for us. So we have team A. I wanna talk about what each team did and what it makes us think of, okay? So team A created 4 pieces of licorice. Let me tape this up here. 1, 2, 3, 4 pieces of licorice, okay? Let me number those because I know it's a little bit tough to see. We have 1, 2, 3, 4 pieces of licorice. What did we say? We have 4 licorice, 3 people, okay? So team A says, well, they get 1 whole piece each, And then we will break this into 3 equal parts. And so each person, here, let's draw my person, gets 1 whole and 1/3 of a piece. Okay? Then we have Team B coming in with a different visual. And it's interesting because these remind me of Caitlin and Isabel's actual visuals that they had shared with me the other day when we were talking about the actual licorice and sharing the 5 pieces among those 3. So Team B came in and said, okay, we see 1, 2, 3, 4 pieces of licorice. We have our person over here. Okay, we're gonna cut each piece into 3 equal parts. Okay, there's 3 people, 3 equal parts, and then we each get 1/3 from each whole piece of licorice. Interesting. Then you have Team C who just threw us for a curveball here. Completely threw us for a curveball. I'm gonna slide down a little bit. My stool here. Let's see, I'm gonna put them right here. All right, you guys. Can you see that? Let me adjust you a little bit, okay? So Team C used kind of a number line. That's what it reminds me of. I wish we were having this conversation in person because I would love your perspective live on what's happening here. And they said, all right, we have 4 pieces of licorice, 3 people. So they represented their 4 pieces here. Then they broke each of the 4 pieces into thirds, okay? So when they put theirs together, they came through and said, ooh, we'll break it into thirds this way and this way and this way, okay? So, which one are you more comfortable with? Which visual model, like right away in your brain, you're like, yes, I connect to that visual model. This one always takes me a bit. I can see here that they would get a piece of this one, they'd get a piece of this one, a piece of this one, and a piece of this one. So I can see that they each get 1/3 of the pieces, which is similar to the here, right? All right, so today with your teams or any of your collaboration partners, thinking partners out there, you are gonna continue to work through 6-15. What are you noticing? What are you wondering about the team A, B, and C and how they chose to represent sharing the licorice equally or fairly? Also, how can you represent it not only with a visual model, but with a number representation? And how does that compare to division? If we go back to the beginning, the question was asking us, 7/5, is that the same as 1 2/5, right? So take some time, work through that. We would love for you to work through 6-15, 6-16, 17, 18. And if you're really feeling up for it, continue through 19. Don't forget, you can check in with us during our office hours to go over any of these problems as you're feeling stuck or you just want to ask a question. All right. We'll see you later.